Hello all, welcome to the Counting Well RMS Prep Live session. We know that the baseline for is already released and we have the final assessment test on 30th April. How to participate? You just have to complete the course in step 1 of the RMS in order to qualify and take the scholarship. The course is designed to help you fill any learning gap from previous academic year and get you prepared for the new class. So, we are here to help you qualify the scholarship. For this, stay tuned to the session and get ready for the test. In this session, I will take you through the chapters: number system, math application and mensuration. But before that, let us go through some of the doubts posted by our app users. So the first doubt is posted by Shivam Bharti from Innovera School, and the doubt is regarding triangular numbers and square numbers. Second doubt is from Seher Zaidi from RAN International School, Noida, Sector 39. And the doubt is on division of rational numbers. Third doubt is from Akshat Anand from RAN International School, Noida. And the doubt is on the chapter mensuration. So, the doubts will be cleared itself in the session. So, please be in the session till the end. Okay, so this is for Shivam Bharti, who has posted the doubt for triangular numbers and square numbers. Hello. So there was a minor technical error. Sorry for the wait. So let us move towards our next slide. Okay. Okay, sorry for the error. Now it's running smoothly. So let us continue. So Shivam Bharti, you will get your doubts cleared. First, we'll see the doubt for Sahil Zaidi. So let us divide a rational number by its reciprocal. So in this way, you can learn or you can understand how to divide a rational number by another rational number. So what is reciprocal? It is nothing but the multiplicative inverse of that number. So to find the reciprocal of the given rational number, we invert the numerator and the denominator. So for example, the reciprocal of minus 3 by 7 is 7 by minus 3. Now the question is to divide minus 3 by 7 by its reciprocal. So let us divide the rational number by its reciprocal. Minus 3 by 7 divided by 7 by minus 3. What we are going to do? Division is converted to multiplication by multiplying the reciprocal. So minus 3 by 7 into minus 3 by 7, this will give you 9 by 47. Now, so our user wanted to know about triangular numbers and square numbers. So these are nothing but number patterns represented through geometrical shapes. Every number can be arranged in a line. So every number we can represent through a geometrical shape. Here it is a line. So for example, the number 2, it can be represented by 2 dots arranged in a line. The number 3 can be represented by 3 dots which are arranged in a line. And we can use this concept for all the numbers. That's why all other numbers can be represented in a similar pattern. Let us see some numbers which can be arranged as triangles. Example, the number 3 can be represented as, you can see here, you can see the two sides have the same number of dots. Here you can see 2 dots arranged in the bottom and 2 dots arranged vertically. So we have a triangular shape here. Similarly, we have 6. We have a triangle having 3 dots at the bottom and 3 dots in the vertical. So you can see how 6 is arranged in the form of a triangle. Similarly, the numbers 15, 21 can be represented as triangles. Such numbers are triangular numbers. Next, we'll see how we represent another number like 21 or 10. You have to note that the triangle should have two sides equal. So when we are representing 10, for example, in triangular pattern, you have to arrange the dots 4 in the bottom row, 3 above it, and then 2 and then 1. What are square numbers? Square numbers are the numbers which can be arranged in the form of squares. Given below some examples, the number 4, it can be represented as 4 dots like this. Or we can see the number 9, how it is represented in the form of a square. Similarly, we can represent other numbers like 16, 25, 36, 49, and so on. So the numbers like 4, 9, 16 can be represented as square. So such numbers, we call them as square numbers. Now let us see what are rectangular numbers. Some numbers can be arranged as a rectangle. So you can see given below are some examples. For example, 6. It can be arranged as a rectangle with 2 rows and 3 columns. So what are rows? Let me show you. So there are 2 rows, 1 and 2. How many columns are there? There are 3 columns, 1, 2, 3. Similarly, the number 12, it can be arranged as a rectangle with 3 rows and 4 columns. So we have here 3 rows, 1, this is second, and this is third. Then we have 4 columns, 1, 2, 3, and 4. Similarly, we can represent the numbers 8, 10, 14, 15 as rectangle. So these are nothing but rectangular numbers. Now let us determine prime factors by division method. So what are prime factors? Prime factors are the numbers which divides a number, and that number should have divisor 1 and itself. So here you can see what is the procedure to find the division by using prime factorization. So start dividing the number by the least prime factor, then continue the division till you get 1 as a quotient, and then collect all the prime numbers and write them as a product. For example, you can see we can find the prime factorization of 220 using division method. So what is the least prime factor? It is 2. Okay. So if we divide 220 by 2, you will get 110. If we divide 110 again by 2, you will get 110 divided by 2 is equal to 55. 55 is divisible by 5, which is the next prime number. So we have 11. Then we have 11 only divisible by 11. So 11 divided by 11 is 1. Since the quotient is 1, now we have got 1. So the division process is completed. Hence, you can see how we have divided. First divide by 2. You will get 110 here. Again divide by 2. You will get 55 here. Again divided by 11. You will get 11. 5s are 55, then 11 ones are 11. Okay, so in this way you can find prime factors using division method. So what are the prime factors of 220? 2, 2, 5 and 11 and 1. Now let us see how to add rational numbers with same denominators. So what are rational numbers? Rational numbers are the numbers of the form p by q, where p and q are integers and q is non-zero. Correct? So you can see minus 24 by 5 and 57 by 5, both are rational numbers. The denominators are same, that is 5 and 5. The rule is very simple. You just have to keep the denominators same and add the respective numerators. So minus 24 by 5 plus 57 by 5 will be equal to minus 24 plus 57 divided by 5, which will be equal to 33 by 5. Let us see the next. Add two rational numbers with different denominators. The following steps we have to follow to find the sum of two rational numbers with different denominators. So the first step is to find the LCM of the denominators. So how to find LCM of the denominators? We'll see using one example. The next step is to convert each rational number to an equivalent rational number with denominator as the LCM obtained. So once you write each rational number with denominator as LCM obtained, you will get two equivalent rational numbers. Okay. For each rational number, you have one rational number which will be equivalent to that rational number. But both of these equivalent rational numbers will have the same denominator. So keeping the denominator same, we'll add the numerators to find the resulting answer. Let us see one example here. Suppose we have to find the value of minus 7 by 6 plus minus 5 by 9. Correct? First, let us find the LCM. So what is the LCM of 6 and 9? It is 18. So LCM here stands for the least common multiple. So how to find LCM? You just have to find the multiples of 6, then multiples of 9, and then find what is the least among the multiples of both the numbers. So if you take the multiples of 6, it will be 6, 12, 18, and so on. If you take multiples of 9, it will be 9, 18, 27, and so on. So if you see, 18 is the least common multiple among the multiples of 6 and 9. Now, as the LCM is 18, so we have to write 6 as 18. So what we are going to do, we are going to multiply 6 by 3, and same number we are going to multiply to the numerator, which is minus 7. So minus 7 multiplied by 3 divided by 6 into 3, which will be minus 21 by 18. Next we'll have minus 5 by 9 is equal to minus 5 into 2 divided by 9 into 2, which will be minus 10 upon 18. Now that we have equivalent rational numbers, minus 21 by 18 and minus 10 by 18, we can add the numerators. So we have minus 31 by 18. Hence, minus 7 by 6 plus minus 5 by 9 is equal to minus 31 by 18. I hope the steps are clear now. First, we are going to find the LCM of the denominators, as the denominators are different. Then we write each rational number as equivalent rational number by taking the denominator as LCM. Okay, then we have to add by adding the numerators and keeping the denominator same. So this will give the sum of the rational numbers given in the question. Let us see subtraction of two rational numbers. So subtraction of two rational numbers is same as the addition of additive inverse of a number to be subtracted. So what steps we are going to follow? We are going to follow these steps. First, again, you have to find the LCM of the denominators. Then you have to find the rational numbers equivalent to the given rational number with LCM as the denominator, and then you have to add the numerators of the equivalent rational numbers and keep the denominators same. Let us try to understand this first. Subtraction of two rational numbers is same as the addition of additive inverse. What is additive inverse of a number? Additive inverse of a number is a number which when added to the given number will give you the resulting answer as 0. So for example, let us find the value of minus 7 by 6 minus 5 by 9. So what we are going to do here, first we are going to find the LCM of 6 and 9, which is 18. So minus 7 by 6 will be equal to, since we want 18 in the denominator, you have to multiply 6 by 3. Same number you have to multiply to the numerator. So you have minus 21 by 18. Next we have minus 5 by 9. You have to multiply the denominator as well as the numerator by 2. So we'll get minus 10 by 18. Now what we are going to do, we are going to subtract minus 10 by 18 from minus 21 by 18. So you have minus 21 by 18 minus 10 by 18. So minus 21 minus of minus 10, taking the subtraction is same as adding the additive inverse. Additive inverse of minus 10 is 10. Okay, so if you add 10 to minus 21, it will be minus 11. So minus 11 by 18 will be the final subtraction. Now let us see how to multiply a rational number by another rational number. To multiply the numerator of the first rational number with the numerator of the second rational number, Then we have to multiply the denominator of the first rational number with the denominator of the second rational number. Then we have to simplify the result to its lowest form. Let us see one example to understand this properly. Let us multiply 2 upon minus 3 by minus 7 by 6. So what we are going to do, multiply numerator of the first rational number with the numerator of the second. So 2 into minus 7 will give you 2 into minus 7, which is minus 14. Then minus 3 into 6 will give you minus 3 into 6 will be equal to minus 18. Neutralizing minus minus from numerator and denominator will get 14 by 18. Converting to its simplest form is you have to divide by the common factor. So we have 12 as common factor. So we have 7 by 9. That's why 2 by minus 3 multiplied by minus 7 by 6 will be equal to 7 by 9. Now, when you are dividing a rational number by another rational number, it is same as multiplying a rational number by reciprocal of another rational number. So when you are dividing a rational number by a number, you have to convert that division into multiplication by taking or inverting the numerator and denominator of the second fraction. So I'll show you how. Let us find the value of minus 7 upon 15 divided by minus 21 by 10. So instead of this division sign, we are going to write multiplication sign. But the main thing or the main change you have to do here is minus 21 by 10. You should write as 10 upon minus 21. Here you are inverting the numerator and the denominator. Means the numerator becomes the denominator, whereas the denominator becomes the numerator. Multiplication, we are going to follow the same rule. Multiply the numerator of the first rational number to the numerator of the second rational number. Then denominator of the first rational number to the denominator of the second rational number. So in this way, you will get the division of a rational number by another rational number. Now let us move towards our next chapter, which is maths applications. Let us first understand what is percentage. Percent is derived from the Latin word per centum, meaning per hundred. Percent is represented by the symbol. So you can see the symbol here. For example, 2% marks means 2 marks out of the total 100 marks. Here the word cent means 100. So percent means per 100. So 2% means 2 per 100. So this is the meaning of percentage. Correct? Or we can write it as percent. Now let us try to express the given quantity as a percentage of a whole when the whole is not 100. So whenever we are writing percent, it means it is per 100. But what if the given quantity should be expressed in percentage of a whole, but the whole quantity is not 100? So in that case, we have to multiply the fraction by 100 and put the percentage sign. The numerator of the obtained fraction is the percentage of the given quantity. To understand this properly, let us take one example. Let us look at this question. What percentage of 2 kg is 400 grams? So 400 gram is a part of 2 kg, but it is of how many part if you take it out of 100? Okay. If it is 400 grams from 2 kg, what about if we take it from 100 units? So 2 kg is, we know, 2000 grams because 1 kg is equal to 1000 grams. So what we are going to do, we are going to first convert both the units to the same unit. Here we have kg, so we have converted kg into grams. Another quantity here or another number is 400. So 400 out of 2000. If you multiply it by 100, you will get per 100. So you have 20%. So 400 grams is 20% of 2 kg. This is what we have the conclusion. Let us see one more example. Out of 20 balls in a basket, 15 are red in color. Let us find the percentage of red balls in the basket. What is the fraction of red ball? Let us solve this problem. The fraction of red balls is 15 by 20. Why? Because there are 15 red balls and the total number of balls is 20. Now, if you want to find the percentage, that is, we need to find out of 100 balls, how many will be red balls. Because percent means per 100. So it is 15 per 20 balls. So how many will be there for 100 balls? Or how many red balls will be there for 100 balls is the question. So we are simply going to multiply 15 by 20 by 100. This will give you 15 into 5, which is 75%. So we can say out of 20 balls, there are 75% red balls. So again, what is 75% of 20? It will be 15. So this is how we can cross verify our answer. So for this, you have to just do 75 upon 100. This is 75% of 20. So here you can see 25 are 100. So if you divide 75 by 5, you will get 15. That's why 75% of 20 balls is 15. I hope this is clear to all. Now let us answer this question. 12% means A parts out of B. What is A and B here? What are A and B in this statement? Yes. It is nothing but 12 parts out of 100. Let us see one more example. What is 0.34 percentage of 400 kg? So if it is 0.34 per 100, then what will be it for 400 kg? Let us convert 0.34 into fraction. For that, you have to remove this percentage symbol and divide it by 100. Now you have to multiply the fraction by the given number. So 0.34 upon 100 multiplied by 400. This will give you 0.34 into 4. So it will be 1.36. So 0.34 percentage of 400 kg is 1.36 kg. Correct? Now let us see how to find the simple interest amount to be paid as the given sum of number, given sum of the money. What is principal? Principal or the sum? It is nothing but the money you are borrowing from the bank for your purpose. Okay. For the borrowed money, at the end, you have to pay some extra amount, and that is nothing but the interest. Then the total amount paid by the borrower at the end is called the amount, the total money. So amount will be equal to principal plus interest. So this formula is simple. Amount is equal to principal plus interest. And this interest are given in percent for a period of 1 year, that is per annum, that is per year. The interest on 100 rupees for 1 year is known as rate percent per annum. So if you are borrowing some money from a bank, you usually check the rate of interest. And that rate of interest is called rate of interest because it is on 100 rupees for per year and it is per annum. So on the principal money or the principal amount, the interest paid for 1 year or the simple interest formula is R into P divided by 100, or it can be written as P into R divided by 100, where R is the rate of interest. On principal P, if the interest is paid for T years, so you have to include here T also. If it is for 1 year, the value of T will be 1. That's why we do not have here T, because it will be multiplied by 1. That is, it will be P into R upon 100 only. So simple interest will be P into T into R divided by 100, where R is the rate of interest. Let us see one problem and let us try to find simple interest or the amount to be paid on the given sum of money. If the money is borrowed 2000 rupees, okay, a person borrows an amount of, or we can say the principal sum as 2000 rupees, and the bank has interest of 10% per year or per annum. The interest that has to be paid for 1 year is 10% of 2000 rupees because he has borrowed how much? 2000 rupees. So let us calculate 10% of 2000. It is nothing but rupees 200. So how much interest has to be paid for 2000 rupees? It should be rupees 200. So 200 is a simple interest to be paid for the principal 2000 for 1 year. Let us generalize this. So if you take the principal, the sum as P, R is percentage per annum. So we have amount, the interest paid for 1 year is, or the principal amount, the interest paid for 1 year is RP upon 100. Now let us move towards our next chapter, which is mensuration. Let us use the formula to find the area of rectangle. Area of rectangle is nothing but length into breadth, and area is usually measured in square units such as square centimeter, square meter, and so on. Now let us find the area of the rectangle whose length and breadth are 12 centimeter and 4 centimeter respectively. We know the length is 12 centimeter, breadth is 4 centimeter. Area is found by multiplying length and breadth. So we have 12 centimeter into 4 centimeter, which is equal to 48 square centimeter. So this is very simple. You just have to multiply the length and breadth so that you get the area, and should be in squares unit. Let us look at one problem. The lengths and breadths of three rectangles are shown below or given below. We have three sets of length and breadth. So 9 meter and 6 meter, 17 meter and 3 meter, 4 meter and 14 meter. So the question is to find which one has the largest area and which one has the smallest. Area of a rectangle is length into breadth. So for the first one, we have 9 into 6. So we have 54 square meters. Then we have the second one as 17 into 13. So, sorry, 17 into 3, which is 51 square meters. Then we have 4 into 14, which is 56 square meters. You can see the three areas are 54, 51 and 56. The area of rectangle with 56 square meter has the largest area, whereas the area of the rectangle with 51 square meters has the smallest area. Next, let us recall the formula and find the area of a parallelogram. The area of a parallelogram is nothing but base into height, which is b into h. For example, here you can see one parallelogram ABCD with height AE. So if we multiply base and height, so here we have DC as a base and AE as the height. This will give you the area of the given parallelogram ABCD. Now let us recall the formula and find the area of a parallelogram, which is given here. The height is 3 centimeter. Here you can see the base is 7 centimeter. So the area of the parallelogram will be base into height, which will be equal to 7 into 3, which is equal to 21 centimeter square. Therefore, area of the parallelogram is nothing but 21 centimeter square. I hope this session was helpful. And after RMS also, if you want to continue to use counting well to keep learning maths, practice and improve your scores and develop good problem solving skills, then you can download the app from the App Store or Play Store. Also stay connected to our channel Counting Well. So gear up and complete the course at the earliest to qualify for the final scholarship test. Until then, keep learning and keep growing. Thank you.